Hello guys, here is TIDEACE. Now follow me to learn how to produce a complete carbon frame. Every carbon frame starts with a 2D drawing. Firstly, the general shape of frame and some basic geometry data must be confirmed, like what it is for, what kind of the frame it is. Okay, as shown in the video is our new enduro suspension frame. Model number is FSA35, but still haven't on sale yet. Well, if any guys have interest on it, contact us. This is a 2D drawing of it. Not like general hardtail mounted frame or road frame, which are relatively simple. Because performance of frame has been determined with designing 2D drawings. But suspension frame requires more professional analysis to determine the pedal's feedback or the chain pull is hard or not. Anti-lifting, anti-squirting, and some basic suspension performance calibration. Okay, we can go next step that making a 3D drawing after the final geometric properties are determined. And here is a 3D drawing of suspension frame FSA35. The 3D drawing will determine overall shape of the frame, the thickness of top tube, down tube, seat stay, and chain stay. After all above, it's necessary to extend to every details, such as bearing size of the pivot point, through axle size, and how big is the plastic plug hole. All of these are finally confirmed at this step, including stacking distribution of carbon fiber materials, how much material will be used in which parts. If some parts of the frame are too slender, but it's the point of force, adjustments will be made to ensure that there's no problem with the frame. Once the mold is open, it's difficult to make changes again. Our mold will be done after confirming the 3D drawing. Now, here we go back to the factory. What you can see are some of the modes, the front and rear triangle modes of road and mountain bikes. Rear triangle modes are made of large pieces of aluminum alloy iron and forged. Because it's large size and heavy weight for the mold processed by 5-axis CNC machine tool. Like the one-piece mold, it can only be moved by forklift. Commonly used and some customized molds will be placed in the downstairs warehouse, and less frequently used molds will be stored on higher shelves. When the design part is completed and the mold is ready, then we can go start produce the frame. The most common used is carbon fiber pre-preg. So what is carbon fiber pre-preg? It's compositing epoxy resin or carbon fiber by high pressure technology. Carbon fiber filament, epoxy resin, release paper, and other materials has been coated, hot pressed, cooled, coated again, rolled materials, and other processing techniques. Finally, processed material is the pre-preg. Now, what we can see is a 3K wave, which is woven and crossed together in different ways. In addition, this is UD wave. Each carbon filament goes in one direction, so there's no plait pattern, which will be better one-way mechanical properties. It's different from 3K wave and has better tensile properties. Now, what we can see is a press feed machine. Multiple sheets of carbon cloth are stacked in the specific direction and then compressed together. Stacked carbon cloth needs to be cut into specified size. This cutting machine is used to carry out manual cutting. Because the length, width, and height of each piece of carbon cloth are very strict, so it must be positioned by a machine to ensure that each piece of carbon cloth is consistent in length, wise, and hate. However, since the frame is composed of thousands of pieces of carbon cloth, there are some irregular ones that can only be cut into a specified shape with the help of numerical control equipment. Each frame composed of hundreds of carbon fiber cloths. There are many types of carbon cloth. The cut materials should be classified, labeled, and placed in a pile, and then sorted and prepared for preforming. This is the preparation of a frame, and as you can see, there are so many types. This carbon cloth in my hand is eddy weave. Each carbon filament goes in one direction, and this one is 3K weave. Every worker who enters into the preforming room must be dusted to prevent dust in the air from polluting the carbon cloth and structure and keep it clean. For example, this corner is preforming a front fork. Firstly, we need to paste the shape of the fork legs one by one, according to the requirements and directions to make a roof shape.
Now, say my name. Heisenberg.
These are parts of the various products that are already preformed. Small accessories are relatively simple and can be integrated in one-piece form. The whole product can be preformed as a whole, and here is a preformed one from front fork steel to legs. After the preforming completed, it will be sent to the mold for forming. And here is a front triangle of rolled frame. Finally, the front and the triangles are combined by gluing and spicing to form a complete frame. Because the video is a little longer, we will make it in short. This rolled frame is formed by a split molding. Firstly, the front and rear triangles are formed separately. Then we will put the release agent on the mold, and the carbon cloth must be prevented from being clamped by the mold to appear folded yarn appearance. And prevent mold pressed here, which will cause poor inflation. If the inflation is poor, the carbon cloth inside won't be tight enough, and determination will happen, affecting the strength of frame. After everything is ready, we can push the frame into the stove. Then, front triangle of the frame is formed after several steps like hydraulic pressure, heating, and air inflation. This is a new formed first suspension frame. As we can see, each frame has a series number. Some of the resin in the pre-preg will overflow, which is a normal phenomenon and will be processed later.
Better call Saul.
This is the rod from front triangle that has just been formed. After a simple procession, there's no excess resin. You can see clearly the visible UD wheel. These cases are rod frames that are ready to be glued after the appearance is processed. Now the front triangle and rear triangle are separated. When everything is ready, they can be glued. Because the ABS and one-piece frame has not been arranged production recently, so we still have no photography at this time, which will be added in next video. Now we come here. The engineer is gluing a road bike, which is formed just now. And you can see that the engineer is positioning every part of the frame precisely. Maybe you will see why it looks so low and old. Actually, it's the best positioning pedestal, because we will make such a CNC pedestal for each frame. This CNC positioning pedestal is specially customized for this frame, which is very accurate. Different from the simple batch positioning platform in the picture. Due to its small size, more frames can be placed in the same oven to achieve high output. Because the fixing method is not stable enough and is not dedicated to individual models, so the accuracy is limited. It will lead to other problems such as the asymmetry of the wheelbase, the inaccuracy of the front and rear center lines of the frame, and other problems. So, we would rather choose a higher standard platform. After the glued resin is completely dry, we will glue the next set of frame and 2 sets one time. The speed is relatively slow, but the accuracy is high. Of course, the cost will be higher too. After the frame is glued, we can go on to the next process. Now, next step is the most important part of each product, ISO 4210 testing. You may ask, what is ISO 4210? It is officially released by the European Committee for Standardization in 2014. A basic safety requirement that was implemented in 2015 was used to ban the previous EN 14781, EN 14766, EN 14764, and other standards. Now, they are upgraded to ISO 4210. In fact, ISO 4210 is just a foundation. For some specific frames, we will add 20% to 30% strength requirements on this basis to cope with different models in different environments, and also have a better guarantee for the safety of frame. For example, some suspension by riders, like flying back, dry falling. Then, our requirements of the head tube will be 30% higher than the requirements of ISO 4210. Which can ensure that riders won't suffer from insufficient strength and lead to safety threats to life in riding. Here are some test videos. Please pay attention to adjust the volume because the test environment is noisy. When a frame is developed, formed, and tested for strength, it can be mass-produced. The next step is painting after massive production is completed. There is refining, processing, and polishing the surface of frame before painting. Now, what you can see is our refinement workshop. In the video, our engineers are sanding an integrated handbar. In order to remove the release agent from the surface, there's a process called sanding blasting before painting work. After sanding off the release agent, it needs to be re-leveled with sandpaper manually because it's not so absolutely flat. After the master finished sanding with coarser sandpaper, he will hand it over to another master with finer sandpaper. After 2 times of sanding, the handbar will become very smooth, which can absorb paint well and make the paint last longer and better durability. Here is sanded suspension-free front triangle. It's different from the frame that has just been mold released. It looks a little gray. This is raw material frame ready to be painted at any time. And here we come to a place dedicated to paint glossy. It's a dust-free workshop. Next to here, where some painted forks and frames are placed inside. Okay, next, let's introduce the painting on frame. It's not painted step by step by our master. It's the watermark as shown in the video. It's a needle similar to a sticker, but it has no adhesive in backside. There are 2 layers of sealing film after it's printed. The middle layer is the watermark we use. It will become soft by soaking in water and has a certain elasticity. It can be adhered to the frame and can be attached to the frame through a certain stretching and positioning. After a certain amount of time in the oven, it will be fully solidified. Now, what we see is Kid's bike frame. It's an OEM painting frame. The worker is using spray gun to paint the frame into glossy. The carbon fiber painting all are finished in low temperature environment. Here is one of the small ovens. What in oven now is aluminum alloy frame, which also uses low temperature painting, but the efficiency is not so high. Generally, aluminum alloy frame will be in high temperature painting, and painting will dry faster. But carbon fiber products cannot. There's a big difference between them. We don't produce aluminum alloy products, but we have a painting department. Here what we see is a manual quality control room. After each product be painted, there will be manual quality inspections to check if there's oil flow or pinholes, the painting is perfect or not, and other details. After confirming that there's no problem, it will be sent to package department for final inspection. If the installation is smooth, and if the screw hole is clean, and so on. And then a good frame will be shipped to the customer from all over the world. Finally, thank you for watching the video. See you next time.
Saul.